Hello everyone, this is AAlMahrooqi. You can call me Abdul since my name is hard to pronounce. Um, this presentation is about KI1, and KI is just basically an assignment that connects all classes we are taking. I'm taking this semester ECE 331, ECE 341, and ECE 311. So I'm gonna talk about power management system and is it how how they all connected, how all the three classes connected in power management system. So I'm gonna talk about the power management system in each aspect of each class. Power management system is in charge of controlling the electrical system. Its task is to make sure that the electrical system is safe and efficient. So let's start with ECE 311. ECE 311. When we look at this circuit, an aspect of ECE 311, which is linear system analysis, this system has two parts, rectifier and RC circuit. So basically we're going to talk about linearity and time difference. Let's define linearity. Linearity is a system which obeys the principle of homogeneity and additivity, and time invariance, a system that make the output doesn't depend on time. So when we look at the output, when we for linearity, when we do anything when we add the input, it has to be equal when we add the output, same as homogeneity. And time invariance, that the output doesn't depend on time at all. So for this circuit, there is this power supply circuit. We'll take first the rectifier. The rectifier is not linear because when we change the polarity of the input is sinusoidal, so the output doesn't change because of the diode, and it also doesn't obey, so it doesn't obey homogeneity. And when we add the input and the when we add the input and the reverse polarity input, the output would be double, but the input is zero, so it doesn't obey additivity, which means this system, the rectifier, is not linear. Then let's talk about time invariance. Because when we change time, when we go and change time, the diode doesn't change in time, so the output doesn't depend on time, so it is time invariant. Now let's look at the RC circuit. The RC circuit, it is linear because the RC circuit is produced by components that are linear, so they create a linear system. About time invariant, the capacitor changes in time, but initially it doesn't change, so we say it is time invariant. It doesn't depend on time initially. So at the end, rectifier is non-linear, RC circuit is linear. The whole system, the power supply, is non-linear because there is a part of it non-linear, so the whole system is non-linear. Then the rectifier is time invariant, the RC circuit is time invariant, so the whole system is time invariant. Okay, let's go to ECE 331. When we look at the previous circuit in ECE 331 aspect, we look at the diode. Diode is made by semiconductors, and we basically learned about diode in ECE 331. Oh, sorry, I didn't say anything about ECE 331. ECE 331 is about electronics. So, diode. The diode, when the diode is on, it's acting as a short circuit, and so the current go through the diode. When the diode is off, it acts as an open circuit, so the current doesn't go through the diode. So let's go back to the previous slide. Um, when diode is on, when the diode is on, I mean at a volt at the positive sign, two diodes are on and two of them are off. So the current goes through the circuit, and then the negative cycle of the sign, the first two diodes will be off and the second will be on, and the voltage will be the other way. Voltage will go the other way. Um, and the diode makes the input more stable, so the full wave rectifier will produce a positive voltage. And let's go to ECE 341, which is electromagnetics. When we look at the diode are made of p-n junctions. Between p junction and n junction, there is electric field which produce electric field intensity. According to Gauss's laws, there will be a potential difference that will be produced between the edges of the cylindrical shape of the diode. Um, so that's the connection between the three classes. So that whole system wouldn't be able to made without these three concepts: linear system, electronics, and electromagnetics. Thank you for listening.